Here's the 511 review preview. Problem 5-8 said graph y equals 1/2 x minus 3 and its inverse function on the same axis. So the first thing that I did was figure out the inverse function. So I just undo the problem. So instead of multiplying by 1/2 and subtracting 3, I'm going to add 3. So I'm going to get y equals x plus 3 and then multiply everything times 2. So I'll get y equals 2x plus 6 is my inverse function. So if I were to graph both of those, so the first one, I'll graph in a different color. The first one is y equals 1/2 x minus 3. So I start at -3, it's right here. I'm going to go up 1 over 2, over 2. So my line should look like that. For the inverse function, I'll do in green. It's y equals 2x plus 6. So you're 1, 2, 3, 4, 5, 6, up 2 over 1. So it's going to look like this. Problem 5-9 says Antonio's function machine is shown at right. What is a of 2? So if I plug in 2 for x, I'm going to get 3 to the second power, which is 9. B says if 81 came out, what was dropped in? So I'm looking for if I have 3 to the x equals 81. And I can just start plugging in numbers 3 to the first, 3 to the second, 3 to the third. Turns out it's 3 to the fourth, so x would equal 4. So 4 is dropped in to get 81 out. Problem 5-11, if 10 to the x equals 10 to the y, what's true about x and y? So x must equal y, and the justification is in order for the powers to be equal, their exponents need to be equal. Problem 5-12 says solve each of the following equations for x. You had to choose at least one to solve. The first two are, you can cross multiply to solve. So I did 5 times x equals 12 by just cross multiplying. So divide by 5. So I get x equals 12 over 5, or 2 2/5. Part B, I cross multiply, get 7x equals 5x plus 5. So I distribute the 5, so I'm going to subtract 5x from both sides. I get 2x equals 5. So I'm going to get x equals 5 over 2, or 2 1/5, or 1/2, 2 1/2. For C and D, they're not cross multiplication, but I'm going to clear the fractions. So I'm going to multiply through by a common factor to get rid of the denominators. So in C, I'm going to multiply by 15. So 15 goes into 15 once, so I'm just left with 6. 15 times 2 is 30. 5 goes into 15 3 times x, so minus 3x. So then I subtract 30 from both sides. I get negative 24 equals negative 3x. So I end up with x equals 8. Problem D, my common denominator is going to be 15 again. So I'm going to multiply everything by 15. 3 goes in 15, 5. 5 times 2 is 10. 5 goes in 3, so I get a 3x. And 6 times 15 is 90. So I get 3x equals 80. So I'm going to get x equals 80 over 3, or 26 2/3. Problem 13, you could have used Desmos to do it. You're going to sketch the solution of the systems. So you would graph each one first. So for the first parabola, the vertex is at 0, -5. And then it's a standard parabola, so it's going to look like this. For the second one, and they're solid lines because it's greater than or equal to. For the second one, it is the vertex is at positive 1, 7. And it's a standard parabola, but it's turned upside down. So the first parabola, the answer was greater than. The second one was less than. So when we shade, you would shade in between.